So guys, I am super, super excited because today we are starting chapter 18, which is, of the whole entire year, it is my favorite chapter of all of the chapters that we cover in the book. You may have noticed that we're actually doing section 9, chapter 9 today. There's some stuff from chapter 9 that we need to review before we can be successful in chapter 18. If you took 161 from me, I honestly can't remember if I even covered this section 9.4. Because a lot of times I'll just save it for 163 and not talk about it at all in 161. So if this doesn't look familiar to you at all, don't even worry about it. That's why we're going over it. We are, in this whole entire chapter 18, we are going to be studying a type of reaction called an oxidation-reduction reaction. So this is just a class of reactions. Like we have an acid-base reaction, we have precipitation reactions that you learned about in 161, we have combustion reactions that you learned about in 161. Oxidation reduction is just another type of reaction. Because there are so many syllables in oxidation reduction, a lot of times we just say redox, where the read part is short for reduction and the ox is short for oxidation, but it's out of order. Oxidation reduction reaction is defined as a type of reaction that involves the transfer of electrons from one atom to another, or from one molecule to another, from an ion to another. So we're just going to say transfer of electrons from one reactant to the other. And the exciting part about the oxidation reduction reaction is that this transfer of electrons moving from one reactant to another, we can harness that. We do harness the movement of electrons, and that's one of the ways that we generate electricity. This is how batteries work. So the redox reaction can be thought of as two separate reactions happening. We can break them down. Can be broken down, and this just means on paper, like we don't actually break them down, but to simplify them, to think about them, we can be breaking them down into two, what we call half reactions. This concept of the half reactions is, to me, it's really similar to the way that we think of and define acids and bases. Like we say the acid is the H plus donor and the base is the H plus acceptor. In a redox reaction, something is the electron donor and something is the electron acceptor. And the two half reactions, one of them is called the oxidation half reaction, and the other is called the reduction half reaction. And the oxidation half reaction is the process or the half reaction that involves the loss of electrons. And the reduction is the process that involves the gain of electrons. And right now you might be saying, oh my God, chemists, why would you call the reduction reducing the one that is actually gaining electrons? That seems totally backwards. And it does. But the word reduction, it actually does make sense. Not in the context of gaining or losing electrons, but it does make sense, which you'll see in just a little bit. You'll see how it does make sense. So one of the ways that you can help yourself remember which is which, we've got a trick. Oil rig, which stands for oxidation is loss, reduction is gain. Oxidation is the loss of electrons, reduction is the gain of electrons. That's how you can remember which is which. Oxidation is loss, and there's other tricks to help you remember as well, but this one is my favorite. Reduction is gain. So here's an example of a redox reaction, and this is actually one that you did way back in 161. You had some magnesium metal and you weighed it, and then you burned it inside a crucible, that little teeny tiny ceramic dish with a lid, and you turned it into magnesium oxide. And that was a stoichiometry lab. So you were like weighing how much product did you make and calculating the empirical formula of magnesium oxide. It wasn't designed for you to be learning about redox at the time, but it totally was a redox reaction. You just didn't even know it. So here are the half reactions of that reaction that you did in lab way back in the fall. One of the half reactions is the two magnesium atoms turning into two magnesium ions, Mg2+. So let's kind of highlight that. The two magnesium atoms right here, and they're atoms, they're not ions, and then they're turning into the two magnesium ions in MgO, that's Mg2+ and O2- right there. The other half reaction that we have is the oxygen O2, and I'm leaving a space here because I'm going to add another reactant. The oxygen molecule O2 turning into two oxide ions, 2O-, O2-. And so that's this oxygen molecule going to the oxide ion. So those are the half reactions. Notice in the half reaction, we're consistent with the atom. So the magnesium is turning into magnesium and the oxygen is turning into oxygen. We're not switching up one type of atom to another. And so let's take a look at how this process is taking place. In the first half reaction here, we have magnesium atoms, and they are becoming magnesium cations. So the magnesium atoms, the atoms are losing electrons and becoming positively charged cations. So electrons are actually being produced in this half reaction. Not 2 electrons, that's the wrong number of electrons. 4 electrons are being produced. Every magnesium atom, every single magnesium atom is spitting out 2 electrons and turning itself into an Mg2+ cation. So we've got these 4 electrons that are being produced during this process. And then likewise down here with oxygen, we are adding 4 electrons to the O2 molecule to produce the oxide ions. So these electrons over here that are produced, they are being added to the O2 molecule and turning it to the oxide ions. So those are our half reactions. And if we look at those half reactions, we can classify them as either oxidation or reduction. If we think about oil rig, oxidation is loss. Who is losing their electrons? So when we're trying to decide which is the oxidation, which is the reduction, we're looking just at the reactants. Did magnesium add electrons? Did we plus electrons to this magnesium, or did it lose electrons? Well, electrons came off of it because they're being produced by the reaction. So this half reaction is an oxidation because the magnesium lost or produced electrons. And then for our other half reaction, we're looking at the oxygen and we're asking ourselves, what happened here? Did the oxygen lose electrons or did it gain electrons? Well, with the oxygen, we added electrons to it. It was oxygen plus electrons. So that means that this half reaction is reduction because the oxygen gained or added or reacted with electrons. And I should clarify that the reduction, I pointed my arrow at the oxygen, but it's the whole entire reaction that is the reduction. And same thing with oxidation. I pointed my arrow at magnesium, but the whole entire reaction is the oxidation reaction. So 2 more definitions in here. We also have what we call the oxidizing agent, and we have the reducing agent. The oxidizing agent is the reactant, the molecule, the atom, whatever. It's the reactant that causes the oxidation reaction. So it causes the oxidation. It's not the thing that gets oxidized, it's the thing that causes oxidation. And the reducing agent is the thing that causes reduction. It's not the thing that gets reduced, it's the thing that causes reducing. The oxidizing agent, the thing that causes the oxidation, is the thing that's being reduced. So for our reaction, the oxidizing agent is O2, and the reducing agent is Mg. That's kind of tricky, defining the oxidizing agent and the reducing agent, but we'll practice it some more.